Hi everyone, hope you're doing great. In this video, I will be building a simple calculator from scratch, starting with the basic concepts and going up until creating the object-oriented calculator. Let's start by downloading Java. In this case, I'm using the Oracle version directly from oracle.com. If you want to use the OpenJDK version, you can use it as well, so it is fine. I'm using Java 18. So once we are here, choose the operating system of your preference. In this case, I'm using Windows, and then just click, for example, in my case, I prefer to use the exec file. Once it is downloaded, you get a file like this one. Just double click it and it will be installed. Accept the permissions. Once you get this window, it is as simple as just clicking next, and it will be installed in your computer. Now we close it, and there is something that I try to do always because this is really useful, and in some cases it is required, is to add Java to the environment variables. So let's add Java to the environment variables. We go to advanced system settings, then we go to environment variables. In this case, let's add Java as one system variable. We just need to click new. And in this case, it is Java home. The variable value, let's browse for it. And this is the one. So JDK18, okay, and save. Now we have the Java home variable defined here, but we need to add the variable to the path. So let's edit the path, new, and it is %Java home. It will be reading the value from the variable that we just defined, and we want to get the bin directory from there. Now Java is fully installed in our computer and it is part of the environment, so we can use it anywhere in the computer, and the default version of Java used in the computer would be Java 18. So we just click OK, and we click OK, and we are all set. Let's do one simple test just for making sure that Java is installed in our computer and it was added correctly to the environment. So let's open a command prompt. In this case, I just need to click home R cmd and just type Java -- version. And as you can see, it is Java 18, the one that we have installed. Now the next step will be to download an IDE. You can use any IDE of your preference. I mean, if you want to use just a terminal or command line, it is fine. But there are many IDEs that you can use. For example, in this case, I'm going to use Eclipse IDE. It is as simple as just going to the eclipse.org site and then clicking here in the download icon. Once it is downloaded, you will get one file like this one. So in order to install this application, just double click it. You will get a window like this one. Once we get this window, we can choose between different versions. We just need some core functionalities, but let's choose the enterprise and web developers version. It will be useful in the future if you want to do some Java web development. Then it will let you choose the installation folder and the Java version. As you can see, it will be taking the Java home variable. So in this case, it is already taking JDK18 that we installed before. Then you click install and you will be all set. In my case, I'm not clicking install because I already have the IDE installed. So let's move into the next step. At this moment, we have installed all what we need. We have Java and we have the IDE. So let's start by opening the IDE, and this is the screen that you will see. For starting, we are going to create a new project, Java project. So we can use this button right here, this link, or we can go to File and then New. It is the same. Then we go to whatever we want to do. If we, in this case, Java project, I don't see it here, so let's go to Other, and you can just type Java. It was already there. Java project. Next. In this case, let's try to configure JRE from our just installed Java. So for you to learn how to do it, let's go to configure JREs. We just need to do it once for this specific version. Then add standard VM. We now need to find the home. It is here. Program files Java JDK 18, the one that we installed. Select. It will be recognized automatically. And then we just click finish and it was added. Let's use that one as the default one. We just need to change the check, apply, and as you can see we are using our JDK as the JRE as well. Then let's assign a project name. In this case we are going to create a simple calculator, so let's just name it something like Java calculator. Then click next and just click finish. And we are all set with the project. Let's now create our first app. So for doing this, it is important to create a simple package at least. So we click new, right click, and then new package. Let's call it something like com.tutorial, or even better, .java.tutorial. Sorry. Okay, and then just finish. It is right here. So now we click over the package, right click it, and then we click new. And now we are going to create a class, our first class. And we can call it something like whatever you prefer, but in this case I will use app. And just for you to know, if you check this field right here, you will get the main created, the main method. So it's just a shortcut. Click finish. And our main method is created right here. And we have all this inside the app class. Before going into the practice, let me quickly explain the basic structure of the Java application. So as you saw, we have the package and then we have the classes, the Java classes. Inside of the Java class, in this case, we have one special method. This is the main. And as you can see, we are passing some arguments to this main method. Why it is important? Because this is a method that the Java virtual machine will look for. Why? Because this is an entry point, the starting point for the application. So this is the one that we are going to use for our testing, and we are going to make it bigger as we go. So inside of it, the first step, what we are going to do is to create some variables just for testing and running the application. But in terms of structure, we have the class. And inside of the class we have methods. Inside of the methods we have variables and code. And also inside of the class we could have variables. Those are the global variables. Let's start with the variables at the method level and some examples. So for creating a variable we need to define the data type, the name, and if we want to assign a value immediately we can do it. So for example, for creating a string, it is string uppercases because this is an object. The name, for example, let's use name of the person, and then equal, and then quotes, double quotes, and the value that we want to use. For example, let's say Carl. And we always need a semicolon at the end, like this. Okay, let me explain how can we print this name. We can use this function from the system class. It is system.out.println. Print and println, we can use both. Print will print, but it is not going to insert a line break. So you will be printing into the same line. And the variable that we want to print. So in this case, we want to print name. We save, and then we can just click run. If this is the first time that we want to run it, we can just click over the main method, run as Java application. As you can see, we got the console and we got the value printed right here. So let's try some different variables. What if we want to create an integer value? So in Java, we can use int, for example, age equal to 21 years old person. What if we want to create a numerical value with decimals? So we can use the primitive double, and let's suppose that we want, for example, the weight and then the value. for example, let's say 70 kilograms or whatever is used in your country, .3, semicolon at the end, and that's all. What if we want to print, for example, Carl is 21 years old and the weight is 7.3. So we can use name, it is already assigned, so Carlos. We can use the operator plus, then a space is, what is next? It is age. So right now we have Carlos is 21 plus years old, then space, and then we want to print the weight, and the weight is plus weight. I just have one small error here. We need a space, and as you can see, we can run the application directly from here because we already run it from here and it was stored, so we can use this button from the top. Let's use it, and here the output. Now let me remove this code. This was just for testing, so let's remove it for starting with real examples. The idea of this tutorial is to create a simple calculator. So let's start with the simplest number, in this case integer, and what I'm going to do is I'm going to create two numbers, num1, and I'm going to create a second number, num2. So what I'm doing right now, let's assign a value to it. For example, num1 equal to 10 and num2 it's equal to 15. So the result, if we sum these two values, is 25. So let's do the operation. So the result of the sum of two integers is also an integer. So sum it's equal to num1 plus num2. Now let's print this result. Save the file and just let me move the console up so we can see everything. Now I just need to run it and the result is 25. The next step will be to do the multiplication. So now we have num1 and num2. Let's comment this line. For commenting we can use two slashes, and then if we want to multiply it is data type, it is an integer, the result of multiplying two integers, and then num1 multiplied by num2. Let's reuse this code and let's print the result, mult, save, and let's run it. So as you can see, the result is 150 as we were expecting. Let's organize the code a little bit. So I'm going to uncomment this line and I'm going to add some text. The result of this sum is plus the result, and I would like to do the same for the multiplication. So let's try it. Okay, we got it. So now I forgot one operation. I would like to add it now. It is the subtraction. So it's really simple. If we subtract an integer from an integer, we get another integer. And then int subs equal to num. Let me see which one is bigger. Just for testing, num2 minus num1. Then I just need to print these values and subtraction. Let's run it and we got it. It is 5. So now we are missing one operation. It is the division. So int division is equal to, and this is something interesting because we are dividing two integers and we are storing that result into an integer. Let me open the calculator for doing this example. What happens if we divide 9 with 4? We get 2.25. But since we are doing an integer division, it is going to store only the integer part of it. So in this case 2. And that's what we are going to do. If we divide 15 into 10, we get 1. But if we divide 10 into 15, we get 0. Let me show you. The integer part is 0. So let's try it. num2 divided by num1. And let's print the result. So the result is 1, as I mentioned. Right now we have 4 operations, but let's make it more interesting. So let me just move the console a little bit down. Let's suppose that we have a second set or pair of numbers. Int num3 equal to, let's say 20. And int num4, it's equal to 40. So if we want to do the sum of these two numbers, we can copy this code and paste it here. Instead, we can say something like sum2, it's equal to num3 plus num4. The result of sum2, it's equal to sum2. And then we can save it and run it. And it is 60. But right now, we can introduce a new topic. As you can see, this code, it's exactly the same as this code. We are duplicating code, and when we are programming, the idea is to reduce duplicity. So what should we do in those cases? Let's remove this code. And now I'm going to introduce the use of function and methods. How do we create a method? Let me put it here inside the class. The accessor, in this case, let's make it public, static. We must define this method as static, and any global variable or similar that we are going to use into our main method must be static, because main is static, and from a static context we can only call and use static variables, methods, or whatever we are using. Public static, what are we going to return? The same as this operation and the name of our preference. For example, in this case, let's make it obvious. So the operation name will be sum. Then inside the parentheses, we define the parameters. In this case, 2 integers, num1 and integer num2. These are the values that we are going to pass when calling this method. Curly brackets, and inside of the function, we can type our logic. So let's suppose that we copy this and we just return sum. Then in our code, instead of doing the operation, we can just call sum num1, num2. Let's comment this code for testing, and if I run it, we should get the same behavior. Perfect. So what if we want to print the sum not from here, instead of that from here, and we don't want to get the result, we just want to print it? So we can rename it as print sum. Instead of integer, the keyword is void. That means we don't need to return anything. Let me move this up. Now we are doing the sum, and then we are printing directly. So if this is throwing an error, this is popping up an error because it is not returning any value. So this assignment is invalid. Let's remove the assignment. Also, let's change the name and let's run it. We got the same result. And we can do it for all the methods. Let me do it for all of them. I will speed up the video. So after organizing the code and adding the additional operations, it will look like this. So we have print sum, print multiplication, subtraction, and division. We are passing the numbers in the same order because if we need to reorganize, for example, in the division, we will organize it inside the method. Then if I run this, we should get the same result. So this works. So where we are right now in terms of the calculator. Right now, we have 4 operations. We pass the values, we print the results. So this is really nice, but I would like to introduce a new topic functionality. And for explaining that, I would like to go to the calculator in Windows. Let's consider this scenario. So we are doing an operation for multiply by 4, and then we get 16, and we want to store this value somewhere, the result of the last operation. So in the Windows calculator, we can use this button. memory add. Then we clear it, and let's suppose that we leave, and then when we are back, we would like to know what was that result of the last operation. So we can use the memory recall. I will keep it simple. Once I click it, I get the value. So it was stored somewhere. Let's move this into our code. How can we store that value somewhere that we can reuse it? For doing that, we can create a global variable. Let's do it for the sum first. I will call it sum memory, and let's initialize this variable with the value 0. Now let's create a simple method. Public static. Let's just print this value. So because of that, I don't need to return anything. I will just name it return void, and the method name will be print sum memory. No value is needed because I will get it as the global variable, curly brackets, and I just need to use system.out.println the result of the last sum was plus sum memory. As you can see, and as I mentioned before, I'm getting an error here. Cannot make a static reference to non-static field sum memory. So this is a static method, but this variable is not static. So let's make it static, and the error is gone. But if we call this method from here, let's comment these operations temporarily. Let's just call print sum memory, and let's run it. As you can see, we get 0 even though we did a sum. What is the problem here? We are not assigning the value to the global variable. So let's go to the sum method. We do the sum, we print, and right here, for example, we can say sum memory, it's equal to sum. Whatever we have in sum, let's assign that value to sum memory. Save, run, and now we have a memory. So we are storing in that global variable the result of the last operation, in this case for the sum. So the memory is working, but as you can see, it is storing the last operation. Whatever we do in regards to sum, it will be stored. If we go back to the calculator, let me clear this, clear the memory. Let me do this. Let's multiply 4 by 4. We get 16. Then we can clear. We don't have anything in the memory. And 3 multiplied by 5. Then if we want to store this specific operation, we can add to the memory. We can clear the memory, or we can just clear the output, call the memory. The result is there. Then if we want, we can clear the memory. And for example, 4 plus 4 is equal to 8, and we can store that value. So as you can see, the result or the values that we want to store are conditional. We choose what do we want to store. So let's do that into our memory for sum. How can we do that? Right now we have the memory right here. We have the print sum, but we want to make this specific action to be conditional. So what can we do? Let's add one boolean. Boolean is true or false. Whenever it is true, we are going to store in memory. If it is false, we don't store in memory. Let's call it something like storing memory. Then let's use a conditional. If store in memory equal to true, this is the same as just leaving like this, then store in the memory. Otherwise, don't store that value in the memory. So let's do one test in a scenario. Let's print sum, but pass false. If we print memory, it should print 0 because we are not storing that result. Right now it says 0 as we were expecting. For the next step, I did some changes. Basically what I'm doing, as you can see here in the console, I added more details to the results. So for example, I added the result of the sum and the operation that we are executing, same for multiplication, subtraction, and here I have a mistake, division. So we are printing more details. Let's see. The idea behind of it is to generalize the use of the memory and make it even better in comparison with the memory that we have on Windows. Why? Because here we just have the result, but we don't have the operation that was executed, at least in the example that I ran. So the idea is to change this value from static int to be static string, and here we will assign the operation that we executed. We don't care which operation it was. If we set the store in memory variable to true, we will store that, starting with the value with empty memory. Then let's see, let's do it for print sum. Let's keep this variable, and now I'm going to copy all this text here, and I will assign that text to a local variable, a string message equal to this, and then I will do the same, just print message, right? That's perfect. Here we have an error, some memory. Starting with the variable name, it should be just memory now, because it will be used for all the operations. Then, instead of assigning the sum result, let's assign the message. Memory is equal to message, and as you can see, it worked. So let me comment all the operations again, and if I run it, so we get all the results, but as you can see here, it looks kind of weird. It says the result of the last sum was, and then it says the result of the sum plus 5 is 5. Let's check it right here. So we should just remove this and just print. Running again, and now it says the result of the sum 5 plus 5 is 10. Let's make it more obvious. So memory, just for us to know that we are printing memory values. Sorry, let's make it more obvious. Let's add the words memory for us to know that we are printing memory values plus the value that we have in memory. And it says memory, the result of the sum 5 plus 5 is 10. Now I will speed up the video, but I'm going to replicate this logic to all the functions. So I did it. As you can see, we are storing memory for all the operations. I move the message outside of the system out, and then if storing memory is equal to true, I store in the memory. Then I print the message, and whenever memory is called print memory, actually it should be renamed to be just print memory. Whenever it is called, we will print memory plus whatever is in memory at the moment. So for example, right now if we have print sum, here we are storing in memory, here we are storing in memory as well, so this value is overwritten, and then if we call this, we should print the value from this operation, in this case 10, as it is here. If I duplicate this print memory and if I put it right here, the value of the memory at this moment is this operation, and then let's replace this with 22, save, just to see the difference, call it, and as you can see, memory right here is 10, and then it is overwritten with 110. So it works. If we want to clear the memory, it is really simple. We just need to create a simple method public static void clear memory it's equal to empty memory. That's right. Before print memory here, let me clear memory, and it should be empty now. Perfect, it worked. So far it looks perfect. It works pretty good. But what if we want multiple calculators? What I mean is, what if we want to store different values in different memories? So right now we have just one memory. I mean, we can duplicate this value and just add multiple variables and then add logic inside of it for handling multiple values. But as you can see, for example, what if we open multiple calculators in Windows? Here I have one, 4x4, it's equal to 16, storing memory, calculator, then 3 multiplied by 3 is equal to 9, storing memory, clear, memory recall, we got 16, memory recall, we got 9. So how do we achieve that in Java? And with this, I'm introducing a key topic. This is the main topic when we talk about object-oriented programming. So what I'm going to do is I'm going to create an object from this logic. So right now we have the app, and this is a single thread. Let's create a separated class for storing one specific calculator. Let's call it uppercase calculator. Inside this calculator, I'm going to copy all these methods. Actually, I'm going to cut. I will paste it here. I'm going to remove the static keyword. Now we will do it with objects instead of static calls. We need to store memory for all the objects that we are going to use. And then this is no longer valid. So let me remove all this. Sort. How do we create a new calculator? By default, this class has an empty constructor that we can call. Let's remove the static from here as well. And we should be all set. This is not a static. And then let's create one instance of this calculator. For creating an instance, we need to use the keyword new. The data type, let's call it C1 equal to new calculator, parentheses, because we are creating an object. Okay, now let's use this calculator that prints some, let's say 10 plus 10, and we pass false because we don't want to store this result into the C1 memory. Let's C1.print multiplication, 10 multiplied by 2. We don't want to store in memory. What if we run it? 20 and 20. Let's 22. Should be 220. And then let's suppose that we want to do a division. C1 that print division. Let's divide 100 divided by 10. But we want to store this in memory. Let's print the memory. Sorry, I put the numbers in the wrong order. This is just for testing. Perfect. What if I put the memory of the C1 right after any of these operations? We get memory, empty memory. Then we get the memory value. Let's suppose that someone is trying to use two calculators, as I explained before. So since we are now in the object-oriented side, we can do this. C2 equal to new calculator. And we can start doing operations for this C2 calculator apart from C1. Memory is apart, operations are apart, and everything is apart. Let's suppose, for example, C2 that print sum 100 plus 1000. 100 plus 1000. Done storing memory. Then we want to do C2 that print multiplication 100,000 by 3 start in memory equal to true, and then let's print the memory c2.print memory. And here I would like to show you that this is a separated memory. If we do c1.clear memory, we should get c2 value from here. So let's run it. So as you can see, memory is right here. The memory is empty for memory 1 of c1. Even if we put c1.clean memory right before printing memory, we should get the same result. I just want you to understand that we are handling different memory spaces. Memory right here. Even though that I clear the memory before calling the methods. So as you can see, here we are using 2 memory spaces for 2 calculators, not duplicated code, and this is a really good example for understanding the basics of Java. So with this, we completed all what I was planning to do in this video, because we covered variables, methods, objects, and now you should have a better understanding of object-oriented programming with Java. Please let me know if you have any comment, suggestion, or question. I will reply to that as soon as possible. And thank you very much for watching, and see you in the next video.